Hello friends, welcome to our channel Ulhaskumar Gokhale for learning. The topic for today is Design Concepts Part 2. Today we are going to learn modularity and information hiding, these two concepts in design. Let us start with the agenda. So in agenda, first we have the monolithic software. Why it is difficult to understand monolithic software. Then we'll study the modular software. Then what is module? Then we'll study module based application. We'll take example of that. And then we'll see the modularization process. Then we'll study modularity and software cost. Then whether we should modularize or not. Should we modularize? That will be the topic. Then next we study the information hiding, and lastly information hiding for modular systems. So let us start with the monolithic software. Monolithic software, that is a large program composed of single module. So it cannot be grasped by a software engineer. That means it is very difficult to understand that software. So you can see here in figure, you see this is a monolithic software. It consists of only a single module. So all the variables, then control paths and the references and overall complexity. So it will make the understanding very difficult. So it is very difficult to easily grasp this monolithic software. So that's why we go for the modular software. So what is modular software? Here we have to break up the software into modules so that we can understand easier, and it will reduce the cost required to build the software. So you can see here the software which was monolithic, it is divided into number of modules. And what is modularity then? Modularity refers to the extent to which a software may be divided into smaller modules. So as we divide the software, so the number of modules are important, and how we divide it, that is nothing but the modularity. Then let us go to what is module. So module is a software component or part of program that contains one or more routines. So here one or more independently modules make up a program. So that is nothing but a component of the. Now if you take an enterprise level application, it may contain different modules, and each module serves unique and separate business operation. That means every module will have certain functionality. Then modules make a programmer's job easy by allowing the programmers to focus on only one area of the functionality of the software application. So team members who are involved in making the software, they will have to focus only on one area of the functionality if they are doing it as a module. Whereas the modules, they will be typically incorporated into the program software through interfaces. So every module will have certain interfaces, and through that it will be put into the software. Then let us see what is module based application. The introduction of modularity allowed programmers to reuse pre-written code with new applications. So modules were created and bundled with compilers in which each module perform a business or a routine operation within the program. That is what. So we have certain pre-written code. So if you want to reuse that pre-written code, so that is put into the module, and then we can just compile it and do certain business operation with the help of that. So if you take example is Microsoft Word. So in Word, it has certain modules which are taken from Microsoft Paint that will help users to create drawings or figures. So that is how the module based application will work. Then let us go to modularization. So modularization is the process of separating the functionality of the program into independent interchangeable modules such that each contains everything necessary to execute only one aspect of desired functionality. That is very important. So a module will have only one aspect of functionality, and accordingly it will have independent and interchangeable modules. Then with modularization, we can easily work on adding separate modules to a program without being hindered by the complexity of other functions. We don't have to bother about the complexity of other functions. We just go on adding the modules, and then we integrate the modules so that it will work as a complete function. So in software engineering team, they can easily work independently on each module without affecting others' work. Then let us go to the modularity and software cost. The effort cost to develop individual software modules does decrease as the total number of modules increase. So as we increase the number of modules, the cost to develop will decrease because each module will take less cost to develop because the size of the module will be smaller. However, as we increase the number of modules, the effort or the cost associated with integrating the modules also grows. That is what the cost of integrating will increase. So these characteristics led to a total cost or effort curve. So that will be shown in the figure. So here in the figure we'll see that M, that is the number of modules that would result in minimum development cost. But here we do not have any assurance that we'll be able to predict M properly. So you can see in the figure, here we have cost per module. Now as the number of modules here, it increases, the cost per module, it is decreasing. You can see this line. And the cost to integrate, I mean, that is shown with this line. So it will increase as the number of modules increase. And the dotted one, this is the total software cost. So the region of minimum cost is here, where the number of modules is nothing but M. So we have to predict M so that we have the minimum cost. Then let us go to the next, that is whether we should modularize or not. So you should modularize, but care should be taken to stay in the vicinity of M. So M is very important. So within M, we should modularize the software. Then under modularity and over modularity should be avoided. That is the value of M, it should be optimum. Then you should modularize a design and resulting program so that development can be more easily planned. So planning should be done as per the modules. Then software increment can be defined and delivered. Changes can be more easily accommodated. And testing and debugging that can be conducted more efficiently, and long-term maintenance can be conducted without serious side effects. So these are some of the advantages of module. We'll see the detailed advantages in the next slide. So first, it allows large programs to be written by several or different people. So a large program is broken down into modules, and each module can be developed by different people. Then it encourages creation of commonly used routines to be placed in the library and used by other programs. Just now we have seen the example of Microsoft Word. It uses the programs which are there in Microsoft Paint. Then it simplifies the overlay procedure of loading a large program into the main storage. So that is again very important. Then it provides more checkpoints to measure progress, because as we complete one module, that means some part of software is completed. Then it provides a framework for complete testing, that is, it is more accessible to test, and it produces a well-designed and more readable program. So these are some of the advantages of modularity. Then let us go to the next part, that is the information hiding. So the principle of information hiding suggests that modules can be characterized by design decisions that each hides from all others. That means we are trying to hide design decision from others. So in other words, modules should be specified and designed so that information, that is nothing but the algorithm and data contained in the module, is inaccessible to other modules that have no need for such information. Say even in the object-oriented programming, we have the function and data, and they are contained within a class. So that information is separated from other classes. So only whatever needed information that will be given to different modules. So hiding implies that effective modularity can be achieved by defining a set of independent modules that communicate with one another only that information necessary to achieve software function. So whatever information is required for achieving the software function, that will only be shared. Other information will be hidden from different modules. Then hiding defines and enforces access constraint to both procedural data within a module and any local data structure used by the module. That is what how the information hiding in object-oriented programming, it is done with the help of classes. So there the function and the data, it is totally hidden from other classes. Then let us go to the benefits of information hiding for modular system. So the use of information hiding as a design criteria for modular systems provides greatest benefits when modifications are required during testing and later on during the maintenance. Then because most of the data and procedural details are hidden from other parts of the software. So here because we are using the abstraction, so the data and procedural abstraction, so that will hide the most of the details. So errors introduced during the modifications are less and likely to propagate to the other locations. So they will not be propagated to other locations in the software. So with this, we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. If you like the video, press the like button, share with your friends and subscribe to our channel Ulhaskumar Gokhale for learning. Then don't forget to press the bell icon so that you get notifications for our future videos on this subject, software engineering. Then thanks for watching. Have a nice day.